The topic to be discussed in this video is use of potentiometer. In Arduino boards. Potentiometer is a 3-terminal device. 1, 2, 3. For first terminal, you have to connect supply voltage VCC. For the second is connected to ground. In between these two, wiper connection is there. That is the output terminal. Output of this is the potentiometer is a 3-terminal device. The signal from the potentiometer is analog, but we want it to be digital so that we can read the value on the screen. Next important point here is the signal from the potentiometer is analog, but we want it to be digital so that we can read the value on the screen. Value on the screen. Here, output is the wiper connection. This is the output from the potentiometer is analog in nature. Analog in nature. Next step is Arduino has a built-in analog to digital converter. Arduino has a built-in ADC, analog to digital converter, creates a digital representation of the analog signal. Creates a digital representation of the analog signal. Generally, Arduino has 6 input analog pins. Arduino UNO has a 6 input analog pins. Range is from A0 to A5. A0 to A5. That means A0, A1, A2, A3, A4, and A5. You choose one of these analog pins, any one of these analog pins. Suppose you have to choose, you will choose A1 as an analog pin. Wiper connection of that potentiometer. This is the wiper connection of that potentiometer is connected to one of these analog pins. Wiper connection of the potentiometer is connected to wiper connection of the Potentiometer is connected to one of the analog pins of the Arduino board. The main function of that analog read pin. That means read the values from the potentiometer and then converted into digital values. Read the values from the analog from the potentiometer, and these values are converted into. Generally, we use inbuilt analog to digital converter. Resolution is resolution of that inbuilt analog to digital converter is 10 bits. Arduino ADC takes 0 to 5 volts and has a 10-bit resolution, which lets it output 1024 digital values. Arduino ADC takes in 0 to 5 volts and has a 10-bit resolution, which lets its output 10024 digital values. That means 0 volts to 5 volts mapped to converted into digital values 0 to 10024. These are the 0 to 5 volts. Set the values. Inbuilt analog to digital converter converts these voltages into digital values from 0 to 24. By using some statement, display these values from 0 to 10024. It will map input voltage between 0 and 5 volts into integer values between 0 and 10023. Write the digital values of the potentiometer part to the serial monitor. It will map input voltage between 0 and 5 volts into integer value between 0 and 10023. This one is the potentiometer. Potentiometer, 3 terminals. The signal from the potentiometer is analog in nature. That is third terminal, middle terminal is this one, 3 terminals. The middle terminal is Wi-Fi connection. This one, middle one. That middle terminal is connected to Wi-Fi connection is connected to Arduino. Arduino has 6 analog pins, A0, A0 to A5, A1, and so on A5. The Wi-Fi connection is connected to A1 terminal, A1 pin of that Arduino board. The Arduino has a inbuilt analog to digital converter, converts these analog values into digital values range from 0 to 10023. That means 2 power 10. With the help of one statement, displays these values on the serial monitor. These are the analog from A0 to A5 are analog pins. It takes the value from the potentiometer and apply these values to inbuilt analog to digital converter. Inbuilt analog to digital converter converts these analog values into digital values range from 0 to 1023. Now we will see with the help of that code and see this one. Wired loop or wired setup. Here we use one important serial begin. Here S is capital, serial dot begin 9600. This one is the speed of operation between computer and Arduino board is 9600 baud, generally bits per second. Here 6 analog Arduino pins are there in Arduino boards. Select one pin. That means pin mode. Select A1 as the analog pin input. Input, close. Wide loop. Integer. Potentiometer value is the pot value. Let it be pot value. Here we use analog read. Analog read, that means from A1. The pot value is assigned to A1 of that Arduino with the help of the statement integer pot value that is equal to analog read A1. A1 means analog pin of that Arduino board. Serial print these values. That means pot value. After conversion, these 0 to 5 volts, 0 to 5 volts are converted into 0 to 1023 digital values. These values are displayed with the help of the statement serial println pot value. Delay and closes this one. Here, first statement, important statement here is serial dot begin 9600, speed of that one, speed of operation between computer and the Arduino board. Pin mode, select 6 analog pins, range from, we have 6 analog pins on the Arduino board, range from A0 to A6. Out of the 6 pins, you have to choose one pin. That means input pin. Output of the potentiometer is connected to output of the potentiometer is analog in nature. Range the value from 0 volts to 5 volts. That output value is given to the input, that means one of the analog inputs. Inbuilt analog to digital converter converts these input voltage values to some digital values 0 to 10, 0 to 3. Select A1 analog pin from the Arduino board that has input. Output of the potentiometer is connected to input of the Arduino board. Both are in analog in nature. After conversion, here integer potentiometer value, that means pot value, with the help of analog read function, read these values. Read these values, that means A1. Serial print ln, print these values, that means pot value. Delay 100 milliseconds. Next, blinking of LED control using potentiometer. Blinking of LED, single LED using potentiometer. Here wide setup. Again serial begin. S is capital. Serial that begin 9600. Here for LED controls we use select digital pin. Pin mode 13 as the digital pin for LED purpose. That means this is the output. Next one more pin mode A1. Digital analog pin. Analog pin is the input pin of that Arduino board. And curly bracket close. Wide loop. Integer pot value. Potentiometer value is equal to analog in nature. Analog read. We use analog read. A connection is established between potentiometer wiper and the one of the analog pins of Arduino board. These values are read with the help of analog read from A1 pin only. Conversion after conversion, print these values, digital values. Print ln pot value. Here the pot value is range from 0 to 10, 0, 23. Select out of these pot values if pot value less than 512. The LED goes high. Digital LED, digital right 13 high. Delay, pause the program, delay 100 milliseconds. Digital write. Low. Delay 100. Blinking of LED controlled by using this potentiometer. Next step is simulate these programs by using Tinkercad. Create new circuit. All component. Select breadboard. Select breadboard here. And Arduino board also. And also select potentiometer. The potentiometer value is 10 kilo ohm. Here Arduino board is chosen here, selected here. This is the potentiometer has 3 terminals. Terminal 1, wiper, and terminal 2. This terminal 1 is connected to VCC, 5 volts. Last terminal 2 is connected to, we have to create ground here. Terminal 2 is connected to ground. This one is wiper. Wiper is connected to one of these analog pins. This potentiometer generates analog value. Output of the wiper means this analog value is connected to one of the input of that analog input pin of the Arduino board. You have to choose A1. Inbuilt analog to digital converter converts these analog values from 0 to 5 volts. This is the 5 volts. Terminal 1 is connected to 5 volts. Terminal 2 is connected to 0 volts. These 0 to 5 volts analog values are converted into 0 to 10023 digital values. This wiper is connected to A1, analog pin of the Arduino board. Now we will read the code and see these values. Here go for text, continue. Serial begin is the important one. S is the capital one. Serial dot begin. $600 speed of operation between computer and the board, Arduino board. We choose analog pin is A1 that is represent here. Pin mode. A1. Here pin mode is closed. Go for while loop. This is the part value 0 to 5 volts. That is the 0 to 5 volts analog values converted into digital values. Okay. Next, integer part. That means potentiometer value. Potentiometer value is equal to plug read A1. Meaning of this one is read the analog values from potentiometer. That is the 0 to 5 volts. And then apply to A1 pin of that analog pin of the Arduino board. And inbuilt analog to digital converter converts these values 0 to 5 volts into 0 to 10023. Now we will see these values. Serial by using this one. Pot value. Play. Hundred milliseconds. At the end of one more bracket is missing. Closing a curly bracket and opening curly bracket and closing curly bracket and stop the simulation. Okay. See the serial monitor. These are the digital values. With the help of serial println pot value, 0 to 5 volts are converted into these digital values. 0, 23 converted to 0. Here, here 5 volts is connected here. Instead of connecting this 5 volts, and this one terminal 1 is connected to ground. Start simulation. Here code is there. Uh, 0 to, by changing this potentiometer value, 0 to 5 volts analog values are converted into. This is the terminal 1 is connected to ground. Terminal 2 is connected to 5 volts, 0 to 5 volts. Wiper connection is connected to analog pin of Arduino board. Therefore, by changing this value from 0 to 5 volts and provide 0 to 10, 0, 23 digital values, 1023 digital values.